Good morning, everyone. Very pleased to be here. This is my first visit to Portugal and Porto, and very much enjoyed it. So thank you to the committee for putting this together. So in the next few minutes, I wanted to talk a little bit about some of the gunshot work that we have done recently. I noticed that the organizers wanted to get this meeting off with a bang, so they put gunshot stuff first. But one of the questions that has often come up in the work that I've done is how repeatable are gunshots and how easy are they to recognize from one instance to another. So the outline of the talk today, I will talk a little bit about just the general gunshot analysis applications and where these things come up in forensic cases. Talk a little bit about gunshot acoustical characteristics and some of the very peculiar things about gunshots that I think are still not very widely understood. Based on conversations that I've had. We'll look at the shot-to-shot variability in an experiment that we did with several different firearms, and then come up with some discussion and conclusions at the end. If I talk at this level, is that overly loud? I'm hearing a lot of echo, but is it okay? All right, good, thank you. So gunshot analysis applications fall into, in my view, two different categories. One would be the real-time what might be thought of as tactical information, and this would be used by gunshot detection systems that might be used in an urban area or certainly by military personnel to detect at the moment that a gunshot happens, maybe where it is, what direction it is, and perhaps something about the firearm. And localizing a sniper might be an example of that. The other type of gunshot applications are forensic reconstruction. This is generally after the incident. There's a recording or multiple recordings of that incident, and then these are examined out of real time, weeks, months, years after the incident to try to identify information about what might have occurred at that time. And also to do some kind of firearm classification is often a request to determine what areas are there. So the work I'm going to talk about is primarily in this latter category. So this is reconstruction after an incident, trying to understand what happened. So gunshots, as we all know, are generally considered to be very high amplitude, but they're also extremely short in duration. Most firearms, handguns, rifles and things like that, the bang of the gun, the muzzle blast, is only a couple milliseconds long. It's barely a pop. We often find in ear witness reports that people will say things like, I didn't think I was hearing a gunshot. It just sounded like firecrackers. And they are so accustomed to the Hollywood or video game version of a gunshot, which is a highly reverberant, very long, a few seconds long kind of sound. And the actual bang of the gun is just a very, very short sound. The other thing about gunshots, and this was mentioned earlier in our other paper, they're highly directional. So depending on where you are located or where the microphone is located with respect to the direction the firearm is pointing has a big effect on the loudness or the intensity of that shot. Quite a bit quieter behind the firearm as opposed to out in front. Now most forensic recordings have considerable acoustic distortion, usually if the microphone is close to the firearm, just because it's so loud, it will overload the microphone or the preamp or whatever the front end of the recording system is. And you also generally will have reflections off nearby surfaces, and so a lot of the recorded signal depends, as we know from any type of recording, on where the microphone is placed. And so understanding those effects and putting all those things together is often an important part of a forensic investigation. So if we look at an anechoic gunshot recording, this is on the left here. This is a very specialized recording with set up in such a way that we can record only the bang of the gun without any reflections. This is for a rifle shot. The sound of the bullet going past the microphone creates a mini sonic boom, so there's a crack of the bullet. The time difference between that bullet shockwave and the bang of the gun is going to depend on the geometry. So if the microphone is off to the side, the time delay between those is shorter than if it's in the front. And if you're far enough off to the side, the shockwave from the bullet won't even impinge on the microphone. So the presence of that shockwave may or may not be there depending on the circumstances. But if you look at the time scale there, the entire event is over in just a few milliseconds, a few thousandths of a second. On the other hand, if we have a reverberant recording that's been made in a typical forensic situation, the duration of that echo may be tens of milliseconds long. Often people who are doing gunshot recognition are using these very long impulse responses to try to do deep learning or some other technique to identify a particular firearm. But keep in mind, most of the information in that reverberant tail is the impulse response of the acoustical environment, not the firearm. The firearm's information is really over in just the first couple of milliseconds of that bang. And you start moving the microphone or moving the firearm's direction, and all of these things are changed. So the idea that we have a signature of a gun, I'm pretty skeptical of that being a good way to approach a forensic problem. So gunshot acoustical evidence can include a lot of different features, including not only the bang of the gun, but other sounds that may be present depending on where the microphone is located with respect to the shot. The mechanical action of the firearm may be detectable, the placement of the ammunition, the cocking mechanism, the ejection of the cartridge if it's a semi-automatic weapon. And I also mentioned at the end here, keeping track of the audio coding issues that we heard about earlier may be another important part of this understanding. Now, in many cases, we have a question about subsequent shots from a single firearm. So if a perpetrator shoots the gun and then shoots it again later in a sequence, many times in the forensic investigation, if there are multiple shots, there's often a question, is it different guns or different shooters, or the same gun and the same shooter, or the same gun and different shooters, or there may be a variety of permutations there. There also often is a question of what type of firearm, and based on some of these attributes, we may be able to answer that sort of question. In many multiple shot recordings, unfortunately in the United States, this is somewhat likely to come up in court cases. There may be a question of who shot first if there are multiple firearms discharged. And then, what is the location and orientation of the firearm may also be important for the forensic investigation. And so the question that we had for our research was, if we have identical shots conducted essentially in a laboratory situation where we're controlling everything, are they really identical? Or are there differences from one shot to the next with the same firearm? And as you'll see here, there are some differences that we were detecting. So the test conditions that we use for this is a specialized recording system in order to get these anechoic or no echo recordings. So we have an array of 12 microphones. They are 1/8 inch Gras microphones. We're sampling at 500 kilohertz, so we're trying to get the entire available bandwidth of the microphones and the recording system. The shooter is on a platform about 3 meters off the ground, and the radius of the microphone array is about 3 meters. And the idea here is that the bang of the gun, the muzzle blast, will arrive at the microphone sufficiently sooner than the first reflection, which is off the ground, that we can record the muzzle blast and then essentially truncate the recording to eliminate the first reflection. And these 12 microphones are sampled concurrently with an analog to digital converter, so we can look at timing differences as well. So we did this test with a variety of firearms, and I'll be talking about 3 handguns and 2 rifles that were used here, and they're shown in the picture. So the marksman would stand on the platform and aim at the target. We'd start the recording system. They would take a shot. We'd stop the recording system to make sure everything was correct. They would place new ammunition or prepare again. We'd start this over, and we did this 10 times in a row. So each shot was approximately a few seconds to maybe 30 seconds between one shot to the next. These were using out-of-the-box ammunition, just commercially purchased ammunition, so we didn't do anything to try to match the load of the different cartridges. We just used them right out of the box. So if we look at how this turned out, and you're going to have some trouble seeing these exactly, but I hope the pictures here are big enough and you can look at them in the paper. For each of the 3 pistols on the top and the rifles below, I've simply cut the 10 shots and just put them together so we could look at them all at once on one plot. Understand actually there were seconds between each of the shots that occurred. And the peaks on here you can see are extremely high, and with this high bandwidth and the small microphones we can actually get a glimpse of how high this shockwave peak is of the initial muzzle blast. Most recordings of gunshots that you see are done with a much lower bandwidth, and you're not really able to see what that high amplitude peak is. But if we look at these, we're noticing that from one shot to the next there are noticeable differences, even though these are supposed to be identical shots. The Glock 19 pistol, the middle image there at the top, you notice there's a pretty substantial visual difference between one shot to the next. And the reason for these differences is one of the things that we need to talk about. But if we were trying to do some kind of comparison of shots in forensic recording and identify, is this the same firearm from one shot to the next? Well, right here, I know it was the same firearm. I was there, so we know that they were identical, even though that there are distinct differences between them. So what impact this would have on a forensic report needs to be considered. To try to get a little bit more at this and not just look at the peak waveforms, we just did a simple energy calculation. So we just added up the squared sample values over the range of the few milliseconds of the muzzle blast and just normalized them. And again, using this, which would be perhaps proportional to a person's judgment about how loud that sound was. Again, it's not been tested in any way. But again, you can see that there are noticeable differences here. That we should probably be able to categorize the difference between one of the rifles at a much, much higher level than one of the handguns, but trying to distinguish between handguns or different shots by the same handgun, I think is something that we need to be concerned about in our profession if we're going to make statements about whether the same gun was used from one shot to the next. So the question, of course, is, well, why are there differences between these different shots? So typically, if the firearm moves between different shots, or the orientation of the firearm changes with respect to the microphone, that will result in a level difference. And I've had previous papers talking about that directional characteristic. The firearm and the ammunition temperature has an effect on the combustion properties of the load of the cartridge. That may have an effect on the acoustics. This has been studied for marksmen as far as the muzzle velocity. I don't know that anybody's published anything on what effect that might have on sound. But since we were doing 10 shots in a row, the later shots, the firearm was warm. The barrel was hot. And the question is there any correlation there? We didn't notice any trend in these 10 shots that would easily be connected to that, but it could be something that would be of interest. I had thought that the manufacturers of these bullets were extremely careful about consistency in the load, and I've discovered that is in fact not true. They're not using pharmaceutical level precision on their weight and the characteristics and the humidity and all these other things, and so generally there's quite a bit of variation from one cartridge to the next. Marksmen who are trying to get very repeatable shots know this, and so they will often load their own cartridges or use match-round cartridges that have been very carefully prepared. But the commercial stuff that a law enforcement officer might use or a hunter generally are not that carefully regulated. The bullet weight, the bullet portion of the cartridge, also is not really, really tightly controlled, so that varies somewhat. And the crimp of the bullet onto the cartridge also tends to vary from one shot to the next. And all of these things presumably have some effect on the ballistics and possibly some effect on the acoustics, and that is an area that has not been studied to any great extent as far as I know. And then just the ammunition load, what exactly the combustion characteristics of the gunpowder is a question. So my advice, kind of wrapping up here, is that when you're asked in a case to determine parameters of a firearm shot that's been recorded, consider these variations that are due to the firearm orientation, the motion between one shot and the next, the possible turning of the individual with a body camera or the rotation of the firearm. All of these things are going to have an effect on the acoustics. Now I think we should be careful to consider the variation that will be present just due to the ammunition differences, and that's something that is in there. So if we're doing multiple shots and trying to correlate information from one shot to the next, I'm suggesting take a little bit of time to consider the sources of variability that might be present just naturally in those recordings. So I appreciate the attention. This work is supported by the National Institute of Justice in the U.S. that's studying this type of work and helping us, and a couple of my colleagues that have been involved in this work. So thank you for your attention.